Recently, when I was at eWaste, I picked up this portable TV AM/FM radio combination unit that would have been around in the mid-'80s, I would say, by the look of things. And the more I looked at it, the more it reminded me of something. That's right, with the 5-inch screen over here on the left and the little portable handle here, it really reminded me of a Commodore SX-64, the portable Commodore 64. At the same time, I've been wondering what to do with my C64 Mini that I've had sitting on the shelf since about a week after I bought this thing, and really kind of lost interest and didn't want to use it anymore. What if I could combine the C64 Mini with this TV and turn this into somewhat of a reproduction Commodore SX-64? Well, that's what I'm going to try to do today on the Retro Hack Shack. Well, if you watch my channel, you know I love doing mods, and I've been doing mods for a lot longer than my channel's been around. I've been doing them for years and years and years with all sorts of things. And, you know, there's not a whole lot you can do with TVs like this, although I am going to have an episode, I swear, upcoming at some point, where I will be reusing a lot of these TVs. But for now, with this particular TV, there's just not a lot you can do with it. There's no stations to tune in. You could certainly use it to tune into radio, and these are pretty inexpensive on eBay or, you know, wherever you can find them. I don't think they cost much more than, say, $50 or so. So I'm hoping that I can find a way to get some video into this, maybe, you know, put a floppy drive on the front or something like that, and turn this into something that looks like a Commodore SX-64, because that system is so cool. And I have not been able to find one. The few times I have found one, they've gone for way more than I'm willing to pay for them. The original Commodore SX-64 would have been a little bit wider, I think, because it had the same size TV screen over here on the left, but it had a floppy drive, 5.25-inch floppy drive horizontally like this, with space for disk storage and stuff like that. Of course, it also had a keyboard that would come off the front of the unit, and you could lay that down. Obviously, you needed the keyboard in order to use the computer, so I'll have to think of some way to do that. Once I recognized what this reminded me of, I just couldn't get it out of my head that this could be a mini Commodore SX-64.
In a world of high technology and ever-changing modes, in a world that's full of make-believe and changing attitudes, are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you. Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you.
Maybe not so many, because actually the C64 Mini, if you know it at all, this is almost real size here. It's very, very small unit, and this is about, I would say 2/3 the size of an SX-64, whereas the C64 Mini is about the quarter of a size of a bread bin 64. So we're not going to get quite as small as that. So maybe this is the SX-64 Micro, or the Micro SX-64. Maybe we'll call it something in between the full-size unit and the Mini, something in between that. The first thing we need to do before I can do anything is just to see if this TV works. So it's got a power button up here. Definitely has sound. Turn that down a bit. Let's see if there's a picture. Hey, there it is. And it's a nice bright picture too. This isn't dim at all. Now, I know that it's color because it says up here 5.5-inch color TV. So this, even though it has static on it right now, this is definitely a color picture, but there's nothing to tune in. But for now, I just want to test the radio, and we'll see if there's anything coming in on the radio. Oh yeah. Now I got to be careful here because I don't want to get a content match. But this actually sounds really good. If I didn't mention it before, this is an Emerson set, so nothing too spectacular there in terms of brand names, but it doesn't look too bad either. Okay, well, I thought, what a better test than could there be than actually using the C64 Mini as the test for this screen. We'll get a really good indication of what it might eventually look like. What I've done is I've hooked up the C64 Mini through HDMI to an HDMI to RF converter that you can't see back there, but it's back in back of the TV there. And then because that signal is not amplified, the best way to use that is to hook it directly up through coax to the back of your TV. Well, this doesn't have a coax input, at least not that I could find yet. So what I did was I hooked that up to an antenna and then laid the antenna, these little rabbit ear antennas on top of the TV antenna back there so that they are literally like an inch from each other. So let's go ahead and turn it on and see what we've got. Oh, there we go. There we go. Okay, so I don't have the C64 Mini on at the moment. All I have is my the converter box, which generates this test signal if you don't do anything to it. There is some waviness, but I'm probably fighting a lot of signal interference in the Hack Shack here. I know it might be hard to see on camera, but it actually looks really, really good to me. And I've got the joystick hooked up here so we can, whoops, I started the game. Didn't mean to do that. Don't know what game this is. Alley Cat, I don't know how to play. I guess I'm supposed to shoot stuff. Anyway, that gives you at least a one idea about how this is supposed to work. So now what I need to do is break this thing open and see if there's a way to get some sort of a composite input. Then maybe I can go from HDMI to composite into this system. So that's what I'm going to do next. The first thing I did was I went ahead and took the cover off and took a look inside the TV. Now, anytime you're working inside of a CRT like this, it's very important that you know what you're doing because there are high voltages present in this system. So please take care, and if you haven't worked on one of these systems, make sure you check with a friend or someone that has so that you know what you're doing and you can work safely. So I'm just testing out, making sure that the CRT is discharged, making sure that all those 20,000 or so volts have left that essentially large capacitor that is the CRT tube. And luckily it has, and there's no voltage left. So I can go ahead and continue to work on this set. And you can see here they connected the grounding wire up here to this strap that goes around the CRT with solder. That's a little bit of a pain because I'm going to have to connect and disconnect this thing about 20 or 30 times during the testing phases here. So every time I'm going to have to go back and solder that thing on. But I guess it's not too much of a pain. I shouldn't complain really, right? Once I disconnected all of the wires that were going on to like this daughter board and the yoke and the neck board and all those kinds of things, I was essentially able just to slide the main board out of the system so I could take a look and start to determine where I could tap into it to insert a composite signal. Okay, so here we have the schematic for the TV, and these are the 3 chips I'm interested in. So there's actually one for this VIF-SIF IC, and I'll talk about that in just a minute. Then there's the video chroma IC, and then down here on the bottom we have the vert and horiz def IC, the vertical and horizontal definition IC. And what we're looking for here is a way to inject the video signal and the audio signal. Now, if you're wondering what VIF and SIF are, VIF and SIF are video intermediate frequency and sound intermediate frequency. And what they do is they take in the video signal and the sound signals, and they create an intermediate signal, so-called, basically, which is helping with demodulation and amplification of the signal as it goes over into the larger video and chroma chip over here. So there should be video coming out of that chip and going into the video chroma chip, and we should be able to see that if we take a look at these chips, if we look at the schematics. So the first one is that VIF and SIF, and it's A7530N, and here it is. It's a Sanyo chip, and if we take a look at the pinout down here, we can see that there is video output right here on pin 16. So that's what we're looking for. We want to see where that video goes after it leaves this chip on pin 16. Now, if we take a look at the Luma Chroma video chip, over here, that we see that there's video input on pin 1. So hopefully we see that that video signal is coming out of 16 on the other chip and coming in here on pin 1. We want to intercept that video signal and inject the composite signal that we're going to be inserting to hopefully make that appear on the TV screen. So taking a look at the schematic again, here's pin 16. And if we follow that dark line around, it goes through kind of an amplifier and then comes down here and goes up. And then certainly it does actually go into pin 1 on the video and chroma chip. And it also goes to a few other places as well, most notably down here to the IC401, the vertical and horizontal chip. And that's good because we want to inject the video signal but still have the capability to adjust the size and the brightness and contrast and things like that. So we should be able to do that if we intercept the signal before it splits off to that chip. Now, luckily, thanks to Reddit, we can make this process a bit easier because this user, Nathan Ninja Cube, over on Reddit has actually done the hard work pretty much for us. And if we take a look at that diagram that he posted, it's the same schematic we were just looking at. And he's saying to cut that signal right there, right before the test point, and use the test point to inject the video signal. Now for the audio signal, there is another chip and it's down here. You can see the speaker down here, 3-inch 8-ohm 1-watt speaker. It sounds really good. But we want to inject the audio down there somewhere. And then over here we have the variable resistor, aka the potentiometer. The volume adjustment is right here on the bottom of this schematic here. And you can see that the output of that goes up here into pin 1 on this power amplifier and then leaves on pin 7 and goes over here to the earphone jack and the speaker. And the earphone jack has a little switch in it so that when you insert your headphone jack into that plug, it actually disconnects the speaker output. The little switch is integrated into that jack. So we can actually get both sound out of the earphone jack and out of the speaker if we inject the sound coming out of that little device I'm going to be using. The audio, we can actually insert the audio somewhere before the potentiometer, and then we should be able to use the potentiometer the same way that we would have before to control the volume of the sound that's coming out of the C64 Mini. So there's a resistor here, resistor 617. I think if I pull one side of that resistor and inject the sound there, that should allow me to get sound control on this thing with the C64 Mini. All right, let's go back and see if we can figure out where these things are and hook up some wires to test this out. But before we look at the circuit boards inside this TV, we have to thank the sponsor of this video who's intimately familiar with circuit boards, and that would be PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. So let's start with the video, and taking a look at the main board here, I was actually able to find where those components were that we were looking at on the schematic, and I was able to attach a wire to the video signal so that we could input the video there, the composite video, and I was able to find a convenient ground nearby. So I've got ground, I've got composite. Unfortunately, later I found that it was actually going to be easier just to cut this jumper wire right here and use that to inject the signal. So I did change that later on in case anybody wants to do this themselves. That is a much better and easier place to make that disconnection and inject the video signal there. Now, as far as the sound is concerned, I was able to make that connection right here. This is where the potentiometer plugs in, or the volume pot slider plugs into the board. And I did pull that resistor out of the board that I mentioned, because if I didn't do that, then we would be getting static as well through the board, in addition to the sound signal that we're going to inject at this point. So I do need to remove that resistor just to disconnect the signal coming in from the tuner so that we don't get that interference. But yeah, all of the rest of the components, including the amplifier, are right here in this little corner. Okay, here we go, the moment of truth. I've got all of the wires, I think, hooked back up to where they were supposed to go. I took lots of pictures when I started, so I kind of figured out where they go. And I've got I've actually got the C64 Mini running right now, and it's connected to this mini HDMI to AV box here, and I tested this out on one of my TVs on my shelf back there, and it does work actually very well. So surprisingly well. The quality looked pretty good. Although, crap, I don't have the speaker hooked up. Okay, now the speaker is hooked up over here on this thing. I'm going to go ahead and plug the power in. Keep your fingers away from live voltage, everybody. Okay, here we go. Fingers crossed. Maybe it'll blow up. Oh! We got sound. Did we get a picture? Come on, baby. No, no picture. Turn it off, turn it off. Okay, so we've got sound, so that part is good, but that single solitary line there was not good. That is not what you want to have. So I need to figure out, maybe I bumped a control or something is off there, because I should not be getting that single line. All right, well, let's try to figure out what's going on here. There's obviously a problem with the vertical deflection, and my assumption is that this mod is probably working okay, or at least it's not causing that problem with the vertical or the horizontal line, which was in the middle of the screen, which was the collapse of the vertical deflection there. So I am going to try to troubleshoot this, and I'm going to start from the CRT and work my way back through the circuit until I can find something that is amiss. So let's take a look at the vertical deflection itself on the CRT. And I happen to know that these are the two outside wires on this particular CRT, because I kind of looked this up before. And what I'm looking for here is to see what kind of resistance there is, because this is basically just a giant coil, and there's two of them. There's one for the horizontal deflection, and then there's another one for the vertical deflection. We know, or at least it appears, that the horizontal is working. So let's look at the vertical coil in here. And you want to do this with your meter set on just regular resistance mode. You don't want to put it on continuance. Well, you can, but it'll probably trigger the little beep in your meter if you're on continuity mode, because there's not going to be much resistance, or there shouldn't be much resistance in these coils. They should come out to be, a few ohms or something like that. So I'm just going to go ahead and probe that, and the meter's thinking about it. Yeah, 9 ohms on the vertical, and that seems fine to me. Now, working my way back from the CRT, there could be a problem either with the wires that are running over the board, or perhaps a cracked solder joint on the back of where those connectors come in, because that connector is on there really tight. So I just want to test from the connector. I've got the connector plugged in enough to make contact. It's about halfway down, but I can get under there and hit the post underneath the connectors here, and I can see whether I'm getting good connectivity from the post on the board all the way through to these two connectors here for the vertical deflection. So for that, I am going to just go ahead and put this in continuity mode. And here is here's one side here. Yeah, I'm 0. Look at that, nothing. No resistance, which is really good. And on this side, yeah, so we're getting through all the way from the board, all the way up to those connectors. And I did check the bottom of the board when I had it out for cracked solder joints, and those joints look perfectly fine. I looked at them through a microscope, and it doesn't look like there's any cracks there. So now what I'm doing on the schematic, I'm just following the vertical deflection here, which is represented over here on this side. I'm following those lines back, and this is where it's helpful. Just even a rudimentary understanding of the symbols on a schematic and being able to trace those lines back and see where they go is actually really helpful. So if we follow those lines back, there's a couple things I want to check. Right here, there is R420, which is going across the coil, essentially. Those two lines are connected together by R420, so I want to take a look at that. And then there's another resistor down here, R420A. Maybe they put that in as an afterthought. I don't know how it got the A designator, but that is going to ground. So I want to take a look at both of those real quick. So these two resistors are really close to the connectors that go to the deflector coils, and can test A420. Comes back as 1K, which is correct. And then A420A down here comes back as 820 ohms, which that is correct. So those resistors are fine. They didn't burn out or anything. So let's keep looking here. Now I also noticed, of course, we could trace all of these things back to, you know, any of these other resistors. Of course, there's the pot for adjusting the vertical size, and then these go back over to the IC over here, the vertical and horizontal deflection IC. That could be bad. I don't think so, because we know it was working when I tested this out. But, you know, it's possible that it could have gone bad randomly. But there's also this line here that's coming off of the, here's the vertical yoke again. Those two lines come off. And then there's a line that goes up here. So let's see what that's connected to. So that goes up. Okay, so there's a diode here, 404. And then this comes over to, looks like the video buffer amp. And then this service switch, KL. Aha, I figured it out. So here's that 404 diode right there, and I was testing that out, and then I was looking at these connectors here, and I thought that this connector, this 2-pin connector here, was connected to the degaussing coil, but then I remembered on the schematic that KL for the service switch and this little jumper here, and it turns out I had the wrong thing plugged into the wrong connector. So there's this little connector here. It's sitting on the thing here, but this comes off the degaussing coil. And it just so happens I've been using, and I do this a lot, the memory of the cable, you know, where that cable falls. I mean, it's been sitting here for, you know, dozens of years, and where this cable kind of falls and wants to go naturally as it's sitting here is usually where the cable plugs in. And this one just happens to fall kind of, looks like it falls naturally right here in the middle of the board, which just happens to line up with that connector there. But that is not where it goes. Instead, where it goes is underneath this board over here. There's an identical connector over there, and it plugs in there. And then that ends up going over here to the degaussing button. And what I was doing was I was plugging in the degaussing coil to that connector right there, which isn't supposed to have anything in it, but it just happens to match exactly the type of connector that was coming off the degaussing coil. And so if we look at the schematic again, what I was doing was I was actually, by putting the degaussing coil in here, which is just a coil, so it's going to have very low impedance and it's just going to create a loop. What was happening was I was grounding or pulling the ground side of this transistor here, you know, I was pulling that over to all of this other stuff on the other side of the schematic. And instead, it should have always been open. So by hooking up the degaussing coil there, hopefully I didn't hurt anything, but that is, I think, why the vertical deflection was off. So I'm going to plug the degaussing coil into the right place, the right connector, and let's turn this thing on again and see if it works. Okay, here we go. The moment of truth. Let's see if my human error was the cause for the loss of vertical deflection in that solid straight line across there. Here we go. That's good. I'm getting sound. Let's see what we get on the screen. Rolling picture, it looks like, but that's okay. Oh, look at that. Ooh, we're getting a picture. We're getting a picture. There it is. There it is. It doesn't look very good right now because the colors and tint and stuff are all off because I was messing with this stuff before. But yeah, I can play around with this no problem and get this thing working. Turn up the, oh, there we go. Turn up the brightness a bit. Yeah, so now it's just time to go in here and do some adjustments. Look at that. That is looking great to my naked eye. I hope it's coming across on the camera, but that is looking really, really good. No problems. Oh man, you couldn't ask for a nicer display for emulating, doing what we're doing, trying to recreate that SX-64 similar feel. That is perfect. Nice. Now that I've confirmed that everything is working, I can turn my attention towards modifying the case and adding functionality needed to make this thing all work together nicely. The first thing I need to do is cut out a slot with a hacksaw blade, which will allow me to put a 3.5-inch floppy drive in here. Unfortunately, when I tried to put the 3.5 drive in the case, I found that this board, which used to have all of the tuner circuitry on it, was getting in the way of the drive fitting into the case, so something had to be done. So by studying the schematic, I was able to trim this board down from about 4 inches down to about 1 inch, only keeping the elements I needed to make the sound work in the final product. The next thing I did was I removed the tuning dial, and what I found out was I could fit a standard power switch in there as well as 2 USB ports, allowing me to plug in a keyboard and the SX-64 mini joystick from the front of the machine. The next thing I had to do was figure out what I was going to do for a keyboard. So I found this cheap USB keyboard on Amazon. It was very thin, and I designed a 3D printed case to go around it. And then I would attach this to the front of the TV to emulate that same experience you would have had with the Commodore SX-64. Now it was time to paint the case, and if I didn't get this right, it wasn't going to look much like a Commodore SX-64. So I went down to my local hardware store, and boy, was there a lot of spray paint to choose from. The guy at the counter recommended this Rust-Oleum Painter's Touch 2X. It's a painter and primer, which is nice, and the aluminum was probably the most important decision I had to make here. I also went ahead and picked up a kind of semi-gloss black and a blue color that I thought might match some of those blue colors on the SX-64. After the paint was dry, I could turn my attention to running all the wires to the back of the case where I was going to mount the hardware. So I cut a hole in the battery compartment and started fitting in things to see if I could get everything to fit inside of here to make everything nice and neat and self-contained. Now it's time for some final touches. I noticed that where the plastic cover used to go, there was this empty space, and so I 3D printed some little splines here, painted them the color that they would have been on the original Commodore SX-64, and now I can fill these in to add a little pizzazz and a little bit more likeness to the original Commodore SX-64. All the rest of the finer details on this particular mod had to be custom made, right down to putting the hyphen in between the SX and the 64 on this reproduction label I made for the back of the keyboard. So if you're wondering why there hasn't been a video in a few weeks, now you know. It was very common for people to pair a monitor with the SX-64, as that little 5-inch screen was very hard to read. And just as I was finishing up the project, look what I found. Yep, it's a Commodore 1702 monitor that I found at eWaste. The sticker on top here says that it's good, but in looking at the power cable, you can obviously see that this thing is a hazard, and you would not want to plug in this monitor as you were touching these cables, because you would definitely get mains voltage pass through here. So yeah, that is not safe at all. That's going to have to be replaced. So after opening up this monitor and testing that the fuse wasn't blown, which it was not, I went ahead and desoldered the old cable, hooked up a new one, and got that passed through the strain relief mechanism here. And now, ready to see if this thing actually works. So I hooked this up to the C64 Mini, turned it on, and bingo! Yes, we're getting a signal. It looks good. I'll clean this monitor up and it'll be perfect to pair with this SX-64 Micro. Now at this point, I was testing the floppy drive out and I could not get it to work. And when I went into the system information, sure enough, I found I was still running the original firmware 1.0, and that there was the latest firmware was actually 1.6.1. After updating the firmware and rebooting the system, I was finally able to see that the system finally gave me the notification that I had an external drive attached. Yay! That means we can actually run games and other programs on this thing that aren't included in the C64 Mini itself. Now it was time to finish up all the little details, so that meant gluing in all of the components like these USB ports and the power switch and getting those all straightened away, as well as securing all the wires and what was left of this board after I cut it apart so that it wouldn't be rattling around all over the place anytime I moved the system. And for me, the little touches really do go a long way. And so that means things like modding this 3.5-inch disc to look more like a 5.25-inch disc that you would have used with the original Commodore SX-64. And now with all those little details out of the way, I think it's time we finally took a look at the brand new Commodore SX-64 Micro. And I gotta say, I'm really excited about how this came out. Using mostly spare parts or cheap parts I found online, I gotta say this thing looks pretty good to me. And when I added the details like the little coloring on the handle here to replicate that round disc that was on the original SX-64, and some of the stickers and some of the detail work, yeah, from a distance, this thing just kind of screams SX-64 in a way that's like, wait, that's not quite right. What the heck is that? And I gotta say, I really love it. Now, again, this was not supposed to be an exact replica of a Commodore SX-64. That wouldn't have worked. But what it was a way to salvage this portable TV and turn it into an approximation of the SX-64. And well, I gotta say, it's really cute and it just looks great sitting here on my table. A couple of things to mention here on the back as well. I really like the way this came out. I went ahead and added some RCA jacks for video and audio out so that I could more easily hook up the 1702. I did that after the fact, but it was as simple as just drilling a few holes where the external antenna went anyway, and just attaching a few extra wires to the board. I also went ahead and created from scratch a replica of the manufacturing label that would have been on the SX-64 and added that to the back as well. I think that just adds another nice touch to match the one that would have been found on the back of the original SX-64. Now, by using careful wire management, I was able to fit everything inside the battery compartment here with plenty of room to spare. I've got my USB power brick, I've got splitters for those cables, so I can remove everything from here and take the case apart whenever I need to go back in and fix something or do some further modifications. By using a special HDMI adapter, I was able to piggyback the HDMI to composite video board on top of the C64 mini board, and that really saved a lot of space and keeps everything nice and neat. I find it really interesting as I'm editing this video that the front of the keyboard case there looks so much brighter than the rest of the case, that silver color, even though the paint is exactly the same paint on both. And it really comes down to the texture of the materials and how different they are, just being a 3D printed part on top of a 3D printed table with a bit of texture and a very smooth manufactured plastic on top. In real life, they really don't look that much far apart. I love the way that this thing comes together, where I can just unplug the cable and plug it in when I'm ready to use it, and adding those blue splines around there, even though they're not exactly perfect, they do really make the whole thing give it a SX-64 look and feel when you remove the keyboard from the front of the case. The quality of the screen on this thing is really good too. I kind of wish it had a darker phosphor on the front here, but I can't really complain. I mean, for a set that was produced in 1988, this thing looks really, really good in person, and you'll have to take my word for it that it doesn't look quite this washed out when you're seeing it with the naked eye. And of course, if you want to get better resolution, just see things a little bit better, you can always hook up a Commodore 1702 like I have here, and everything works just great with that as well. I've seen loads of pictures on forums and in groups where people are sharing pictures of what their setup looked like when they were younger, when they had one of these things. And it looks like a lot of people really were using this dual monitor setup, especially for doing word processing and things like that that are really hard to see on a small 5-inch screen. And here I'm loading Impossible Mission, not from the ROM on the C64 Mini, but actually from that 3.5-inch floppy. You can see it there actually blinking as it's loading Impossible Mission. And so you can sideload, all kinds of games and get that experience that you used to have of sticking that floppy in the floppy drive and loading a game from the actual floppy disk. How cool is that? And yeah, if I didn't mention it before, this thing actually sounds great. Whether you're playing the sound out of the Commodore SX-64 Micro itself or out of the 1702 monitor. Either way, one or the other, they both sound fantastic. So there you have it, the Commodore SX-64 Micro, something that never existed before I found this portable TV at eWaste, and now here it is. If you happen to be coming to VCF West, I may bring this with me for the next show so people can actually see it in person and play around with it. So be sure to look for me there at next year's event. Now, here's a couple of tips for those of you who may be thinking about taking on a project like this. First of all, I'm going to go ahead and put all of the products that I purchased to use in this build down in the description underneath the video so that you can just click on those. Those will be affiliate links, by the way. They don't cost you any money, but they earn me a little bit. But if you want to get the exact things that I used in this project, you can find that down there. Also, there's a couple of products I used that I would highly recommend, even though I am not sponsored by either of these. The first one is this Rust-Oleum 2X spray paint, which was amazing. I actually didn't prep the top of the plastic here in some parts. Some of it was sanded, some of it was not. But even the parts that were not, I got really good adhesion with this Rust-Oleum Painter's Touch 2X on bare, clean, of course, plastic. So 3 coats, 2 minutes apart, and this thing was done. So most of my time was put into taping and prepping the plastic and all that. And really just a little bit of time was put into painting because of the awesome coverage and adhesion I got from Rust-Oleum Painter's Touch 2X. So highly recommend that one if you're painting anything plastic. Also, this E6000 glue, I could not have done the project without it. It allowed me to get a really strong bond when I needed it. There were a couple of times where I had to go back and take parts off, and because you can actually remove the parts, even though they have strong adhesion, you can actually go in and remove them. I was able to make modifications as I worked my way through this project without ruining things as I would have if I would have used super glue or something like that. So again, E6000 glue, keep it in your repertoire and use it when you're working on projects like this. It really is good stuff. Now, for those of you who want more information, I've actually uploaded an extended version of this video to my Patreon page. So if you're a patron or you're thinking about becoming a patron or you want more information, just go sign up for a month on Patreon and you will be able to download the extended version with a lot more details about some of the things that I went through as I was building this project, some of the ways that I had to cut circuit boards to make them fit and that kind of thing that was kind of making the video kind of long. I thought some of my patrons would like that. So that's available as kind of bonus content on my Patreon page. So go check it out and support the channel. With that, I can't think of anything more to say except this has been an awesome project. If you like Commodore 64 videos, I will put a link to a few more that I think you might like, and I'll see you over there in those videos next.
End of line.